This is example 2 in section 3.3, the factor theorem. So what we have here is we have a polynomial that's being divided by x minus 2. They give us the remainder. The same polynomial also has a factor of x plus 2, and they want us to determine the unknowns m and n. So if I know the polynomial is being divided by x minus 2, then I can sub in 2 into my polynomial. When I do substitute in 2, it tells me the remainder is 20. So I know that P of 2 equals 20. I also know that the same polynomial P has a factor of x plus 2. Now, if it has a factor, we know that when we plug in negative 2, the remainder should be 0, because that's what we did in the previous section. If it's a factor, we know that the remainder is 0. Once we have two types of information, I can plug into my polynomial the x values, and I can create two equations. So here we go. My cubic is written up here just to remind you. So I'm going to plug in 2 wherever I see an x. So I have m, 2 squared, n, plug in 2, minus 6. Now I still know all this equals 20. I'm going to cube it and then times it by 2. So 2 cubed is 8, 8 times 2 is 16. 2 squared is 4, 4 times m is 4m. I have a 2n, then I have minus 6 equals 20. I add up my like terms, so I have 4m plus 2n. I know that 16 and negative 6 is positive 10. And I'm going to isolate my variables. So I'm going to subtract 10 from both sides, and then I'm going to end up with 20 subtract 10 is 10. So this is my first equation. Do the same thing for your second number, negative 2. This time you're going to plug in negative 2. So we got to be careful with our negatives here. I'm going to plug in negative 2 again. I'm going to plug in negative 2. And I'm going to have minus 6, but this time it's going to equal 0, because remember, we knew it was a factor. When I evaluate it, I get negative 8 times 2 is negative 16. I get negative 2 squared is 4, so I get 4m. Negative 2n subtract 6 equals 0. Then I have 4m subtract 2n. I'm going to bring in my constants, and I'm going to add 16 to both sides. I'm going to add 6 to both sides. So then I'm going to end up with 16 plus 6, which is 22. Now, I have two equations. Now, these two equations can be simplified because I can divide it by a constant to reduce it. So let's take a look at this one again. 2 can be divided into all of my terms. So if I divide by 2, I end up with 2m, 1n, and 5. If I divide by 2 here as well, it just so happens they're both 2, I get 2m minus 1n equals 11. Just easier to work with, that's all. Now, two equations, two variables. That's great. So I'm going to put one on the top, put the other one below it, and I'm going to solve this system like we did in class last week. So in order to solve, you want to isolate or get rid of a variable. I'm going to get rid of it because I can add these two equations, and the 1n and the negative 1n will cancel when I add. But I will still end up with 2 and 2 is 4m. I'll end up with 11 and 5 is 16. Now I can solve for m, and m is 4. I can do the exact same thing with the two m's. So I'm going to write down my two equations again. So 2m, plus 1n. I have 2m minus 1n equals 11. Now, I want to get rid of my m's this time, but do you see how they're both positives? One of them got to be negative. So I'm going to times the top one by negative 1. So then I get negative 2m minus 1n equals negative 5. Keep the other one the same. And now, if I add, the two m's go away. I'm left with negative 2n. I'm going to have 11 subtract 5, which will give me positive 6. I will divide by negative 2, and n will end up being negative 3. So my two values that I was looking for is m is 4 and n is -3.